I don't think I have any Is it recording?
Yes.
At this point, Bennett will remain a good boy and not say bad words.
Good boy.
I know. Why do you all do that? I forgot my calculator.
Caden's only compliment.
Boy.
I didn't say that.
Keep saying it over and over so it gets in the video.
Stop.
Good.
Y'all say the same thing. All right. Now, we are going to do, we're going to find limits. Obviously, you can do it by graph, okay, but we need to be a little bit more accurate. We need to also learn how to find limits by table, and then even that really isn't as accurate as doing limits algebraically. So on Monday, we will learn the algebra stuff, okay, and you'll have a worksheet to do, and then we're done on Tuesday. I'm not going to do anything on Tuesday for you.
No more limits or like no?
No, we're just done with notes. We'll come back and then we'll kind of refresh over this stuff and then begin. But today we're just going to do tables because you can use tables, using tables to find limits. And they are very helpful if you come to a point where you're like, man, I don't know how to find the limit of this. You can use the tables in your graph to find limits. And actually some of the questions they'll give you in calculus will be using tables. So, for example, I only got 4 problems to do here. The limit as x approaches 3 of x squared minus 9 over x minus 3. I think I'll just put them all here. No, I'll just put 2. The limit as x goes to 0 from the left. The limit as x approaches 0 from the right of the same function. And the limit as x approaches 0. And then I got 2 more and we'll do them. And like I said, I'm going to show you, you're going to pick up probably a pattern where you can do algebra, and we will use algebra because it's more accurate. But if you were to graph this function right now, which you should know what this graph looks like, this is actually going to factor, and the x minus 3's will cancel, correct? There'll be a hole in the graph then. When remember when your factors cancel from top to bottom, you have a hole in the graph? Okay, so this actually will look like a hole at 3, 1, 2, 3. And the hole will be at 6, I think. 1, 2, 3, 4. There we go, 6 here. And you will just be up, 1 over 1, up, 1 over 1, but you look like this. Okay? But I think I did plot that wrong. I think it's wrong, but it's fine. What you're going to do is you're going to put this into your calculator. Second y equals, what am I doing? Alpha y equals is what I want to do. There we go. X squared, come on, minus 9. And then on the bottom, x minus 3. Okay? And again, if you look at it, you can see that's going to be your graph. And you'd say, okay, as I'm approaching 3 from the left and then as I'm approaching 3 from the right, looks to me like they're both going to 6. And you can look at it visually at the graph for that. But if you weren't allowed to do this, you could also look at a table. And the table's going to help us for things we do in the future. So how do I look at the table? Once you plug it into y equals, you're going to go to your table set. Okay? And you're going to make your table set be a very tiny change. So we're going to start at 3. Do you see how I changed that to 3? And then I'm going to make the delta table be like 0.01. Sometimes you might have to make it 0.001. Sometimes you need to make it even tinier, but 0.001 is usually your standard one. We did this last year, if you remember, in like pre-calc when we were doing continuity things. Then you hit second table and you go up 2. And do you see how it says error there? Why does it say error?
There's a hole.
There's a hole, okay? Holes don't matter, though, with limits, because it's what you're approaching, okay? So if you were trying to show work using a table form, you'd say, here's my work, 2.98, 2.99, that's the limit approaching 3 on the left. This would be me getting really, really, really close coming from the right. So again, this is your right, this is your left. Left, think less. Right is greater than, left, less. So if I'm looking, if I'm approaching at a very, very tiny increment, 3 from the left, my data says I'm 5.98, 5.99. That looks like it's approaching what value?
6.
6. Okay. And then this one obviously says error. This will be 6.01, 6.02. Same thing going this way. As long as these two are approaching the same number, that is your limit. Okay? So again, you can use a graph for this, or you can use a table, but we're going to use tables for this specifically. All right? So now we're going to do this one. The limit from the left, the limit from approaches 0 from the right, and then the limit as x approaches 0. So I'm going to type into y equals my absolute value. Do you remember where to find absolute value in the calculator? Math, num, abs, 2x, and then divide by x. Okay? I'm going to go to my table. I'm going to start it at 0 and let it go up an increment of 0.01. And I will go up 2. Okay? Now, because this is left, you only look at the less than table. You do not look underneath the right of it. So if you were graphing the table for this or looking at the table, you would make something like this. You'd say negative 0.03, negative 0.02, negative 0.01, 0. And all of these values are negative 2. This one's the error. Well, what are they approaching then from the left only? Negative 2. That is the limit on the left. Remember, you can have a left-handed limit. The left-handed limit is negative 2. This one, though, wants the right side of 0. So the right side of 0 on the table, you would then do the ones that are greater than 0, which is 0.01, 0.02, 0.03. And all those are 2, 2, 2. This one's your error. This side is approaching 2. That is the right-handed limit. It's a 2. But if I don't have a sign here, you're going to put what? D and E. Why? Because those aren't the same. Do you understand that difference in your head? This is really important. You can have a left-handed limit, negative 2. You can have a right-handed limit, positive 2. But if I don't put a little sign there, the limit doesn't exist then. Now, visually, because those of you who are visual, you're probably like, I don't like your table. Some of you like the table right now, but visually, if you don't know what this looks like, these are just 2 lines. That's why their limit doesn't exist at 0. There's a jump right there. Okay? It looks something like this. Right? Yeah, 1, 2, that way. That's what you're looking at. So that's why, as for those who are visual, you're like, oh, to the left, yeah, it's approaching this. Oh, and from the right, it's approaching 2. But they're not approaching the same thing if I say both of them. Chase.
So our work is just drawing out.
Table, yeah, for this, yeah. Drawing a table for this. Shockingly enough, you'll have a table on your first test. And it'll say, what are these values approaching? And you're kind of like reading a table. All right, last 2, and then we're done. Here's another way that this can help you. The limit as x approaches 4 of 1 over x minus 4 cubed. And this is the last one. The limit as x approaches 4 of 1 over x minus 4 squared. And again, sometimes it's good to look at the actual graph itself, and because again, everybody's different, but sometimes it's good to look at the picture, the table, excuse me. All right, so put this in my calculator, go to y equals, gonna go alpha y equals, and do 1 over x minus 4 cubed. I'm going to go to my table set. I'm going to go to what value here? Where do I start it at? 4, because that's what I'm more concerned about. And go up by 0.01. Okay? Okay, so I need you to look at these numbers on the table. Very important. Okay? Do you know what E5 means? Times 10 to the 5th. That means that decimal is moving over to the right 5 times. Yes?
Right.
Okay? This one is moving over to the right 6 times. Very large numbers, okay? So if you were to write this out, in a table form, at 3.98, you have negative 100, and then move it over 3 spots, or 5 spots, 1, 2, 3, 4, 5, negative 130,000. But then at 3.99, at 0.01 more, closer, 0.01 closer, you have Y values that, the Y value is negative 1 million. What are those approaching?
Infinity.
Close. Negative infinity. These are getting very large negative. By the way, negative infinity and positive infinity are limits. They are. You can reach an infinity limit. You can reach a negative infinity limit. I know that's crazy.
So, how's it a limit? It's infinite.
It's the limit. You can have the limit to infinity. To infinity and beyond.
Infinity goes forever.
There's no limit?
But if I go from this side of 4, now look what I have. I have, it says 1e to the 6, which is 1 million. And this one is, shockingly enough, 125,000. So I even lost. What are these values approaching?
Infinity.
Positive infinity. These are not the same. This is D and E. If they were the same, then that would be your limit, if infinity is your limit. Now, why is that? So again, I want you to kind of look at the graph for this, because you want to see, like, what are you talking about? So let me show you the graph, okay? Of course, it's on my calculator here. There is an asymptote, which you all know about asymptotes, at negative 4. 1, 2, 3, 4. Okay? So watch this. As you approach from the left of 4, where's the arrow headed? Down to negative infinity. It's very, very, very tiny. But as I approach from the positive side, it's going to positive infinity. Okay? And that's how you can read it on a graph. Now, sometimes they actually give you answers and they both look like they're going to 1 million, and they're not. If they go to very large numbers, you might want to change your decimal to be 0.001, because then you'll see it'll go at 0.0001, it'll go to like 10 million. So you want to change your decimal just to double check, or look at the graph, because I think the graph makes more sense. What's this one going to be? So let me just show you real quick, and then we'll be done. Y equals. I think I just made it squared. Okay? And just to look at the table, look right here. 2,500, 10,000. 2,500, 10,000. A lot of students get this wrong and they say, oh, it's going to 10,000, Mrs. Seta.
No, infinity.
No, it's going to infinity. And just to show you, let me just show you. I'm going to change my table to be 4 and be, watch this, 0.001. Really tiny. 'Cause what does the calculator do? The calculator is plugging in 4.001 and 4.0002, and they're getting a value for y. Watch what happens to these y values. They now get 1,250,000 when you just change it that little bit. That's why it's not going to 10,000, Mrs. Hetta. It's not, 10,000 is not the answer. It's 1 million. And again, what does this picture look like? Just to show you, there is a dashed line at 4. This is that volcano shape, if you remember learning it last year in pre-calc. Volcano, volcano. Can you see how both of them are headed toward infinity? Right? They're both headed from the left and from the right. They're both going to infinity. And guess what? That is your limit. Done. That can be a limit. Infinity. Welcome. Okay? Just another way to do it. That's it. That's all for today. Tomorrow, next time we'll do algebra.